Hello guys. Now in this video, I would like us to look at Taylor series. Now we already established that the Maclaurin series is expressed as this. And let's just say if we have, it expresses function in terms of its derivatives at x is equal to 0. Now if we add some small h onto the x, then we would have f of x plus h being expressed as f of x plus h, f prime of x, and this is basically the usual form of Taylor series. If you look at this and this side by side, they are actually quite similar, and Maclaurin series is basically just a special type of the Taylor series. Now, how do we go about solving questions involving Taylor series? So let's say you're given this particular question here. So express sine x plus h, sine x plus h as a series of powers of h, and evaluate sine of 44 degrees correct to 4 decimal places. Now, in order for us to express sine x plus h, so we know the Taylor series formula. So we will first of all express sine x plus h. This is our f of x plus h, which is supposed to be equal to f of x plus h, f prime of x plus h squared over 2 factorial, f double prime of x plus h cubed over 3 factorial, f third prime of x, and so on. So we will first of all start by identifying what our f of x is according to the formula. Our f of x is just sine x without the h. Okay, and what's our f prime of x? That's the second term here. So this is the derivative of this, which is cos x. Our f second prime of x, differentiating this, you get minus sine x. Our f third prime of x, differentiating this, we'll get minus cos x. Our f fourth prime of x, this will give us, so differentiating this, we'll get sine x. So replacing these values into the formula, we'll have our sine x plus h is equal to f of x, which is sine x, plus h, f prime of x, which is h cos x, plus h squared over 2 factorial. So this has a minus here, so we'll have minus h squared over 2 factorial, f double prime of x, that is sine x. And then this also still has a minus, so minus h cubed over 3 factorial, f third prime is minus cos x, so the minus is here, and then we have the cos x there. So basically, that's our expression of sine x plus h using the Taylor series. Now the next part says, and evaluate sine 44 correct to 5 decimal places. Now, in order for us to get the value of sine 44 degrees, we can be able to express this as sine 45 degrees minus 1. Now, since we already have a plus here, I want to write it like this, plus minus 1 degrees, so that you can clearly see that the minus 1 is the value of the h. So if we want to get the answer to this, this is definitely our x and this is our h. So if we replace the values in this expression here, we will have sine x, that is sine 45 degrees, plus h, our h is minus 1 degrees, which we will definitely have to convert to radians. So we have minus 1 degrees out there, cos of x, which is cos of 45 degrees, minus 1 degree squared over 2 factorial, sine of 45 degrees, minus 1 degrees cubed over 3 factorial cos of 45 degrees. Okay, so we evaluate that. Remember, we need to convert 1 degrees into radians. So 1 rad is equal to 57.3 degrees. So what of 1 degrees? And everywhere where there's the 1 degrees bit, we will write it in radians. So converting that and then putting all those values into the calculator, we should be able to get the answer as 0.69466. Now notice that in here, I use 45 and not 43 plus 1 because 45 is a special angle. So with or without the calculator, we can still be able to just get its value. So it's easier done that way with a special angle. So let's say if you're given probably to evaluate something like sine of 63 degrees, then we would write it as sine of 60 degrees plus 3 degrees because 60 is a special angle.